Welcome to the last lecture of week 10. We have discussed the manufacturing processes throughout this course, and in this week we have discussed about machining. In machining, specifically the single point cutting tool nomenclature and the kind of the tool materials, the kind of the tool designs, those were discussed in the first part. Then we started talking about the machine tools, about the lathe machine, milling machine, grinding operations, those were talked about. Then certain problem statements on calculating some parameters, for instance the speed, the single point cutting tool, angles. Then we also talked about calculating the tool life based upon the kind of the tool material and kind of the speed of cutting that we have. This was very simple tool life equation that we discussed. In this lecture, I will give a demonstration, the virtual laboratory demonstration on the machining processes. Here I am having on my dashboard the virtual laboratory on manufacturing processes. So, this is the home page that you could see. So, there are a list of experiments here, technology used, people feedback. Let me click on the list of experiments. Two experiments are there. One is lathe machine, second is CNC turning. I am zooming it out. Let me go through the lathe machine first. In the lathe machine experiment, we have introduction, pre-quiz, that is the pre-test questions that we had seen in the previous lectures as well. Then we have post-test questions which are here as in the form of quizzes. We have the theory of the topic which is under discussion. Here the lathe machine is the topic, and the procedure to run the simulator. We have the simulator here and the references are also here. In introduction, the general introduction about what the lathe machine is, when did it start? It started in 18th century, invented by David Wilkinson, and components of the lathe, different components of the lathe and the functions of the lathe like headstock, bed, main spindle, tailstock, lead screw. In feed mechanism, different kinds of feed mechanisms were discussed, the belt mechanism and gear mechanism. Belt mechanism is also there for quick working, but there is always a slip. Why this slip happens? This you can understand while going through our course, the basic mechanical engineering 1, where we have discussed differentiation between the belt drives and gear drives. Gear is a positive transformation, there is no slip at all. In belts, slips could happen. So, belt feed mechanism is here, gear feed mechanism is here. So, this is a simple gearbox or gear feed mechanism that is shown here. Carriage is very important, saddle, apron and tool post are components of the carriage. Then in the theory, we have the block diagram that how does lathe machine work. There is feed from the right to left direction. There is a tool that goes in the upward direction here, that gives the depth of cut, and there are two major components. One is carriage, another is tool post. The carriage gives us the feed, the tool post gives us the depth of cut. Those two would be given or will be presented here in the simulator as well. So, let me just go through the quick relationships that we have discussed: the cutting speed, feed, depth of cut, machining time, etc. Pre-quiz questions, that is to have a readiness to understand the simulation. There are only few pre-quiz questions here, only 5 questions. First question is, which machine is known as mother of the machine tool? Lathe is the correct answer. Second question is, lathe cannot produce internal features like holes. It can do. Internal boring is also possible. So, this statement is not correct. I will mark false. Which type of feed is needed in turning operation? For turning operation, longitudinal feed is required. Longitudinal feed, as I said, is given by carriage in the direction or in the direction parallel to the axis of the workpiece. The cross feed is perpendicular to the direction of the axis of the workpiece. So, here for turning operation, longitudinal feed is given. For taper operation, both cross feed and longitudinal feed could be given. So, here the answer is longitudinal feed. Which type of surface is produced by turning operation in lathe machine? We get cylindrical surface. Majorly the lathe is known to produce cylindrical surfaces. Flat surfaces are produced by milling, by shaper machines or by planer, etc. lathe bed is usually made of, cast iron, because it is a very bulky portion and cast iron has property of self lubrication or so, that helps us to develop the lathe beds. So, these are the general materials used. I will submit it and all of them are correct. Now, let us come to the objective that is given here for the experiment. The main objective of the lathe machine is to remove excess material from rotating workpiece by hard cutting tool, identify important components of lathe machine such as headstock, tool post, bed, tail, gear chain, lead screw, carriage, cross slide, legs, etc. Set the position of the tool, set the spindle speed of chuck and feed rate, simulate lathe machine to obtain desired shape and size. Procedure is given here. Procedure has certain steps. This would be the kind of the interface that we will have in the simulator. It says it has 3 panels, left, right and middle. Left panel shows the instructions of simulator, right panel shows the control keys to operate the lathe machine, middle panel shows the lathe machine simulator. X and Z rollers are used to place the position of the tool manually while machining. Darker roller indicates Z positioning wheel and lighter roller indicates X positioning wheel. We will see when we come to the simulation here. So, for changing X coordinate, there are steps given here. These steps you can read. Set the desired spindle speed by using control keys. Control keys are here on the right hand side, and turn on the spindle by clicking the forward button. This is a forward button here and this is off. This is the spindle rotation. Switching off the spindle rotation, rotating the spindle in the forward direction, rotating the spindle in the reverse direction. These buttons are here. So, continue the same feed and depth of cut to obtain desired shape and size. Let me come to the simulator now. There is a link to the simulator. I click on this and it opens in a new window. So, this is left panel, middle panel and right panel. Right panel is my control button, middle panel is the display, left panel is the instructions also. I will just go through the display and the middle panel. Middle panel, they say this dark circle shows my Z direction. If I try to click here and try to rotate it, you can see this is moving. So, I will just reset it. It is Z is at position 0.3 and X is at position 1.5. If I try to rotate X by one complete circle from 1.3, it turns to 0.9. That means one complete rotation is around 1.3 minus 0.9, 0.4 millimeters. And for Z, if I make a one complete rotation from 3, it gets to 7. This is again 0.4 from 3 to 0.7. That is one complete rotation is giving 0.4 movement to my tool. I will reset it. If I come to this interface here, while using my roller on the mouse, I can zoom in and zoom out. While clicking the left button, I can pan and try to see it from the different direction. For example, if I try to see from this direction whether the tool has engaged or not, this could also be seen. So, I am just zooming it out so that we try to see it clearly. So, let me reset it, and here while clicking the X or Z alphabets here, I can input the value. For example, if I click on X and I just click 2.0, and here there are options increment setting or absolute setting. I say absolute, X turns to 2.0, and if I click on Z and I say 3.0, again absolute setting, it is set to 3.0. So, from here also values could be put in here. I will restore it or reset it to the original position. Now, let us see how do we try to do some machining here. Again, Z is giving me the movement of carriage. The carriage is being moved left or right in the Z direction here. This is Z direction, and X direction is movement that is in the cross direction. So, let me reset it once again and try to see it closely, so that I try to see the tool being fed here. Right. I will now move X forward so that some depth of cut is given. Let me try to first see where does tool touches. .37. If I even trying to move it further, it is not going further because now the tool tip has touched the workpiece. So at 1.37 it has touched. So I will now bring it back, move it to the right, just simulating the lathe machine, and 1.37 it was the contact to the workpiece. From 1.37 I will reduce it by maybe 0.05, 1.37 minus 0.05 is 1.32. So this is manual setting. I am rotating the mouse manually. Just this mouse is being rotated while clicking. So there could be some error. So there could be some precision errors. So because this is all manual. Also when you rotate the carriage, it is also a manual rotation that you do. So 1.32, that means 0.05 depth of cut is chosen here. Then I will now start the spindle and try to rotate my carriage towards left. You can see this turning is happening. Slowly it would go, though it is not showing the surface finish here, but it depends kind of surface finish you require. Accordingly, you need to set the speed of the rotation of the chuck, and feed, this longitudinal feed is also to be set accordingly. Now the diameter is in such a way that 1.32 is my position of the x coordinate. I will bring it back, take it to the right once again. This is how you actually do. We rotate the carriage wheel clockwise so that my carriage goes away from the workpiece. To bring it close to the workpiece, it has to be rotated anti-clockwise. This is the exact simulation that it is showing now. Now 1.32, next step I can make another 0.05 reduction. 1.32 minus 0.05 would be 1.27. Now I will do one more step, that is I am now doing step turning. One diameter, then a smaller diameter, then a smaller diameter, and so on. Now I am moving my carriage again. So this is the next step that is going on. Right, then bringing it back, taking it further. So it has come to 1.35 here, x position, from 1.35 . So this is, I am trying to do step turning here. You can even watch this closely from any of the direction, the way it is going, just for the view. So I will now bring the tool back and I can stop this while pushing this off button, spindle off. So this is a step that I have produced. So this was not very precision specific dimensions that we wish to do, just to demonstrate that how the lathe machine operates, and this simulation is developed accordingly. So this was a virtual laboratory simulation on lathe machine. Let us try to see further questions or anything that it has. Yes, it has one quiz here, that is a post test quiz. This quiz somebody has already taken. Let me try to mark the right answers. Process of removing unwanted material from a block metal in the form of chips is called, it is metal cutting. So metal addition is there in the additive manufacturing, where the material is added. It comes in the form of the filaments, it comes in the form of the sheets, it comes in the form of the powder. It is being added and there is no wastage. In metal cutting, scrap is there, that is the chips which are produced, those are also going as waste. Second question, machining parameters on lathe are speed, feed, depth of cut, all of these are the parameters. Lathe bed is usually made of, again the same question, it is made of the cast iron. Which of the following lathe operations require that the cutting edge of the tool bit be placed exactly on the work center line? Exactly at the center line, which of the following parameters? Boring, facing, drilling and turning. In facing, we need to put it exactly along the center line, because facing is when the workpiece, this is rotating, this workpiece is rotating, on this face we try to do that exactly along the center line it is done, so that it is correctly performed. Question 5 is, in lathe machine the carriage and tailstock are guided on. Carriage and tailstock, carriage is for longitudinal movement, tailstock is for cross movement. These would be obviously guided on different guideways. Same guideway is not correct answer, so different guideways, B is the correct answer. The power is transmitted by lead screw to carriage through, it is transmitted through half nut. Tool life is most affected by machine. Tool life is most affected by multiple parameters, but what we have studied is cutting speed is one of the major parameters that determines the tool life. Let me submit, all of them are correct answers. So, this was the virtual lab simulation on lathe machine. I am coming to the home page once again of the virtual lab on manufacturing processes. Let me come to the list of experiments. Lathe machine we have seen. Let us now try to see CNC turning. CNC turning, computer numerical control, though this course limits itself to the conventional machining processes, there are computer numerical control machining processes. The machining is completely controlled by computer. There are different components other than the regular components which are there in conventional machines. We have the control panel where we feed or enter the feed, depth of cut, the speed and everything. Also the programming, MDI, manual data input, programming could be added there. The G codes are there which helps us to give us the complete code to get the specific component or the part to be manufactured through the CNC machines. So, CNC machines is a self-contained numerical control system for a single machine tool, including a dedicated mini computer controlled by stored instructions to perform some or all the basic NC functions. So, there are certain kinds of CNC machines. It has come through general terms, that is direct numerical control or industrial robots. There are certain do's and do nots. So, that in instructions, if I say make sure that the power button is off when we try to take care while working on the machine, fixing the part in the chuck is the step, loading the tool, calibration, that is known as homing of the machine, that is important. Let me come to the theory part. CNC machine, CNC system is described here. We have machine tool control, then we have in process compensation, that is adjusting the errors sensed by gauges and probes, recomputation of axis position, offset adjustments for tool radius and length, adaptive control adjustments to speed and feed, computation of predicted tool life and selection of alternative tooling when indicated. Improved programming and operation features are there. Diagnostics are there. NC machines are complex and inspection systems. The complexity increases the risk of component failures which lead to system downtime. So, diagnostics are very important here. The types of CNC turning could be, there could be CNC chucking center, CNC universal turning machine, and depending upon the degrees of rotation, it could be 2.5 axis, it could be 3 axis, 4 axis and 5 axis. 2.5 axis machine, only the regular lathe machine that you see, the longitudinal cross movement is there, kind of a 2 axis machine. 2.5 could be another manual feed could be given. 3 axis is, the third axis also is there, Z action could also be controlled. In the 4th axis, the angle could also be given to the tool post. In the 5th axis, the spindle that you have, that could also have a swivel movement. So, there are certain axis or kind of the degrees of freedom that enhances when we have 5 axis machine. Advantages of CNC machine is flexibility in operation, machine adjustments, program can be prepared rapidly, faster prototype, applications are certain. Nowadays, when we say subtractive manufacturing, in the case of the mass production, CNC centers, or those are known as sometimes VMC, vertical machining centers, are used for producing components in a rapid way. So, Only the point is the coding has to be there, the G code has to be there. Additive manufacturing is an alternative which gives us the versatility, the kind of the complexity in the design of the component if it is there, that is more readily produced in additive manufacturing. But for mass production, producing maybe hundreds or thousands of components on a single machine on a single day, still CNC machines are being relied upon. Let me try to come to the pre-quiz questions. The depth that the tool is plunged into the surface is called, the tool is plunged into the surface, this depth we have studied, this is called depth of cut. Speed and position in CNC can be controlled using, the speed and position is controlled by slide table and spindle. For CNC machining, skilled part programmers are needed. Yes, skilled part programmers are needed because part programming is akin to what we do manually. If we suppose manually do an accident, you give a deep depth of cut and a tool tip breaks. Similar could happen as an accident in CNC machining when the code is not put correct. So, skilled part programmers are needed. In machining of workpiece, the material is removed by drilling is an operation. Melting happens in casting only. It is by shearing action. You saw the shear plane in the problem statements when we saw it is by shearing action in metal cutting when the material is removed. How many ways CNC machine tool systems can be classified? It could be classified into multiple ways, but what we have seen here is 3 ways. Let me submit correct answers. So, objective of setting or developing this virtual laboratory is to study CNC turning machine, to perform experiments on CNC turning machine like step turning and facing, to understand the cutting mechanism of the CNC machine. The procedure is given here. Click on the link of the simulator tab, keep the values between 0 and 2, there are certain sets of the values. Let us come to the simulator and try to see what is it trying to represent. So, this is CNC simulator, we can zoom in, zoom out, we can pan. So, this is workpiece, this is spindle, this is chuck, that is when we rotate the spindle, this chuck would rotate, and this is turret. The CNC machine has turrets which holds between 8 to 24 different kinds of tools in it. It could be drilling tool, it could be slotting tool, it could be facing tool, it could be maybe truing dresser for the grinding wheel, etc. So, multiple tools could be held. So, this is a turret that we have. Now, spindle motion, we have to put some value for the spindle RPM. Let me say, suppose if I put value only 50 RPM and start. So, it has started rotating. I can stop it from here. CNC machine also is just like that. You have a start button, you have a stop button for rotation of the spindle, for feed, etc. So, if I suppose here give only the value as 5 rotations per minute start, you can see how slow is this rotating. It is 5 rotations per minute. If I suppose turn this to 500 rotations per minute, it is rotating very fast now. Let me just keep it a number such as 200 rotations, it is rotating now. I can stop it. Then position of the tool, position of the tool could be set at any point. This is the speed at which this position would come, 0, 1, 2, 3, they have suggested to keep it between 0 and 2. Let me keep this value as 2. If I start it, you can see the tool moving toward the workpiece. This is moving towards the workpiece. I stop it. If I set this value as -2, it will go in the opposite direction. So, it is going away from the workpiece. So, this is here x direction here in this CNC setup. Now, here y position setup, let me say this value as 1, I start it, tool is coming towards the axis. So, it will come down, this is y direction. If I suppose increase the speed, let me say I stop it, increase the speed to 3, then start, it is coming at a faster speed, again stop it, increase the speed, let me say to 8 and start, see it is going very fast now, I will stop it, I will put here -2 and try to bring it up. Stop. Now, Z position, let me put value 2 and start, it is coming towards this direction. Now, the major concern here in the CNC systems is the connection between three. There is workpiece, there is machine, and there is the software. When I say machine, machine is holding the tool. The tool and workpiece, then when they contact, the software should understand that this is a zero position. When workpiece has the tool contact with it, this could be set as zero position. This zero position is set here, that this is zero position. From here, incremental coordinates could be given. Like example, 0.1 inside, then 0.1 mm inside, then it suppose has to be 100 mm towards left, then 100 mm going left, etc., etc. So, these things we generally do. So, this is some general machine setup. Let me just try to touch it. I will touch it from this direction. This also will bring here more left side, stop. Then I will bring the X position close, little faster at speed of 3. Stop. Now, slowly moving the Y direction. So, towards negative side, I have to put -1 here. So, this is where my tool touches. This was just a CNC setup. Let me come to the post simulation quiz here. So, what does CNC stands for? CNC stands for computer numerical control. What type of motor is used to drive CNC machining center axis? What type of motor is used? We use servo motors, because small buttons have to give us a big change. Servo motors are used. Machine tools have heavy components. The depth that the tool is plunged into the surface is called as, this is depth of cut. Feed is measured in the units, that is very well known to you now. It is measured in length per revolution. CNC machining centers do not include operations like milling, boring, welding, tapping. It does not include welding. Milling, boring, tapping could be there in the one machine itself. In the turret, we could have different tools corresponding to doing milling, corresponding to doing boring, that is the internal hole enlarging, and then tap could also be held on the turret. Next, which of the following is not the advantage of CNC machines? Higher flexibility, improved quality, reduced scrap rate, improved strength of the components. Strength is not even related to the kinds of CNC machines or so. Yes, higher flexibility, improved quality, reduced scrap rate is definitely there. For CNC machining, skilled part programmers are needed. Yes. When referring to CNC operations, an excessive surface cutting speed will result in, excessive cutting speed could result in many unwanted things. For example, workpiece could have an indentation that is not required. The tool tip could break, the tool could break, there could be chatter in the machine. Here, out of the options, extended tool life, a longer time to machine the workpiece, rapid tool wear, decreased use of coolant. Rapid tool wear is the correct answer. Let me submit, all of them are correct. So, this was a virtual demonstration on the conventional machining, that is the lathe and CNC turning was taken. In the next week, we will talk about the non-conventional machinings. Thank you.